Hey guys, welcome to week 1 of our distance learning notes. These notes can be found in our Google Classroom under week 1 notes. Also, I've printed it on the back. You don't have to, but we also have the week 1 independent practice. That's going to kind of be like your homework, and we'll talk more about that in a minute. These notes, you don't necessarily have to print. You can just follow along with me here on the screen, or you can print them and take notes yourself. It's totally up to you. You will need some notebook paper to write along with us if you're not writing directly on the notes. All right, so up here at the top are some information for you to read. I'm not going to bore you to death by reading it all to you, but I am going to kind of explain what it says. So there's 2 skills that we're talking about here: determining area and perimeter. We already talked about this unit a little bit before we left, but we're going to go ahead and talk about them in the composite figures kind of realm as opposed to just a simple figure. So before we found the area, remember, area is the amount of stuff inside a figure. Perimeter, on the other hand, is the distance around a figure. So it's this side plus this side plus this side plus this side. Area is the stuff inside. Perimeter is the stuff on the outside. So the way that we're going to do these composite figures is I like to cut them into as many shapes as necessary. Maybe you'll have 3 shapes, 4 shapes, more or less. We're going to look for the shapes that we have formulas for. It's not going to help us to make like a star shape because we don't have a formula for the star shape. We're going to determine the area of each section and then add them up. All right, so let's scoot down here to some practice problems because I believe in learning through practice. All right, so problem number 1. If you notice here, we've got like 3 or so shapes. The first shape that I notice is this obvious triangle right up here at the top. So I'm going to go ahead and put a little number 1 in that space. The second shape I notice is right over here. That's that rectangle looking guy over here. And then the third shape would be this rectangle over here. So what I like to do in my little workspace, I'm going to use this space off to the side. I'm going to label it with 3 sections. So the first section I have, and I'm going to label it with that triangle shape, just to remind myself what I'm working with. Then I'm going to draw a little line, and the second shape I'm working with is a rectangle, and the third shape I'm working with is another rectangle. Okay, now that I've got my workspace defined, I'm going to go ahead and write the formula for each of those 3 shapes. Now, you probably have a formula sheet from before the closure. If you don't have one, you can always find them online. I definitely recommend using the SOL formula sheet because it's the one that you're going to be using at school for many years to come. If you would prefer, you can just Google the formulas. It's totally fine. Once you write them down on your piece of paper, you're not really going to need the whole formula sheet. You can just refer back to those formulas once you have them written. All right, so the first problem, we're finding the area of these 3 shapes. So the first shape is a triangle. The formula for finding that area is 1/2 base times height. 1/2 base times height. Formula for finding a rectangle is going to be length times width. And the formula for finding the area of the third rectangle, again, will be length times width. Now that I've got those formulas written down, I don't really need that formula sheet anymore. All right, so let's talk about the triangle. We're going to work one shape at a time. The base of our triangle, that's going to be this long dotted measure here. Unfortunately, we don't have a measure written there. A lot of people are going to want to use this 12 down here at the bottom. And actually, that 12 is wrong. If you notice, that 12 is talking about this whole side here. It's not just talking about the base. So to find that base, we're going to have to do a little bit of quick math. If we know this long side is 12, and we know that this short side right here is 4, I know that this plus this is going to have to equal 12. This little shape plus this big shape is going to have to equal a total of 12. So what I'm going to do is 12 minus 4 to find that the base of this triangle is, in fact, 8. So I'm going to do 1/2, leave it as a fraction. Remember, Ms. Bond always has to talk about fractions. Your base is going to be 8. And your height of this triangle is going to be 3. So 1/2 of 8 is 4 times 3 gives me an area of 12 centimeters. What? Squared. Remember, area is always squared. All right, so our second shape is going to be a little bit faster and easier. That's going to be that rectangle. We're going to do length times width, which is just 5 times 4, which everybody knows is 20. And then our last shape is going to be our length times width. We already found the length here because we found the base of that triangle. So part of the work's already done for us. So we're going to do 8, that's this side, times this side, which is also 8. Again, a lot of people are going to want to use this 12 because it's sitting down here and we never wrote down 12, but it's extra information that the presenter is giving you to try and see if you're going to take it and mess up the question. All right, so now that we've got our 3 areas, don't forget your units. Whoops. Now we're going to add up those 3 areas. So we're going to do 64 plus 20 plus 12. So over here, I'm going to write A equals 12 plus 20 plus 64. I'm going to finally grab my calculator because this is the first time I'm using my calculator and type in 12 plus 20 plus 64. And I'm going to get 96 as my total combined area. That's 96 centimeters squared. Now let's go ahead and find the perimeter. The way that I'm going to find the perimeter, or the way that I like to find the perimeter, is I'm going to pick a corner. So I'm going to go ahead and start right here, and I'm going to circle that corner. That's going to be my starting point and my finishing point. What I'm going to do is in one line, I'm going to draw all the sides of the shape. So I'm going to start on my way down, and I see this figure, this line right here. So I'm going to write P equals 8. As I'm drawing the sides, the first side I drew was an 8. Now I'm going to go down here and draw the long side. This is why they included that 12 there. You needed it to find the perimeter. So I'm going to do 8 plus 12. Now I'm going to find this side of 5. This side is 4. Uh-oh, I don't have a measure here. Again, I'm going to have to do that quick math. I know that this long side over here is 8, and I've already used 5 here. Maybe you're ahead of me and you've already figured this out, but 8 minus 5 is going to give me a missing measure of 3. So I'm going to continue to draw my shape and draw a plus 3 and another plus 3. Now, we get to a slant here, this slanted side, and we don't have a measure for that slanted side. But what we can do is the Pythagorean theorem. We have a right triangle up here at the top, and we have 2 sides, and we're solving for a third. We're going to quickly do the Pythagorean theorem off to the side here. And we're going to do 3 squared, that's my first leg, plus 8 squared, that's my second leg, is equal to that third side that's unknown. So I'm going to go like this and do 3 squared plus 8 squared. And then I'm going to take the square root of that to get this long decimal. Now, I know that we're not going to use that long decimal in our problem. It's only going to confuse us. So I'm just going to shorten it to 8.5. You can do the same if you have to do this on your own. So I'm going to do plus 8.5. Now that I have all the side measures, now notice I didn't use this 8 in the middle, and I didn't use this measure. There are some measures that we're not going to use on the inside because our perimeter is only the distance around the shape on the outside. So all those extra lines we're not going to worry about. So I'm going to take my calculator and just add up all those numbers. 8 plus 12 plus 5 plus 4 plus 3 plus 3 plus 8.5. And I get a perimeter. I'm going to write it right up here. P equals 43.5 centimeters. Remember, perimeter does not get a square. It doesn't get anything extra. So my 2 answers for this question, perimeter equals 43.5 centimeters, and my area is 96 centimeters. Let's go ahead and talk about the second problem. It says this figure is formed by a square and an isosceles trapezoid. So before I continue, I'm going to go ahead and cut this shape into those 2 figures. A square down here at the bottom, that's going to be our shape number 1. And an isosceles trapezoid, that's our shape number 2. Determine, now I know your problem says the area and perimeter. I went ahead and crossed off area. There's some information missing to find the area that we don't have to solve for. So we're just going to worry about the perimeter, okay? So let's talk about these different sides. An isosceles trapezoid, that's a special type of trapezoid where the 2 slanted sides are the same measure. So if this slanted side is 5, we also know that this slanted side is also 5. They also told us that it's a square a square and a trapezoid. Because it's a square, that's telling us if one side is 10, this side is 10. And if that side's 10, so are both of these sides. Now we can go ahead and find the perimeter. Again, pick a corner to start with. I'm going to start right up here, and I'm going to draw my figure. The outermost sides would be this 4 right here. So I'm going to write a 4. Then I get to this side, which is a +5. I get over here to a +10. Down here, another +10. Right here, a +10. And the last side would be a +5. I'm going to add all these up. 10 plus 10 plus 10 is 30. Plus 5 is 35. Plus 5 is 40. Plus 4 is 44. And that would be inches, nothing. We're not putting a square there because this is talking about perimeter. All right, number 3 asks us to solve for the area. We're going to work on this one. Now, I know there are 5 shapes here, but if you notice, it says that it's a square-based pyramid. So a couple things about that. That means that all 4 of these triangles have to be exactly the same in order to make a square at the bottom. So realistically, we're only talking about 2 shapes. So I've got up here, I've got a triangle, looks something like that. And then down here, I've got a square, looks something like that. Squares are easy, so we're going to start there. Our square has a side measure of 1.5 times 1.5. We know it's a square because it says so in the problem. So I can just do 1.5 times 1.5 to get 2.25 centimeters squared. Now I'm going to go ahead and do the triangles. So let me cut my little workspace here. The triangle formula is 1/2 base times height. And we're going to find the base of the triangle is going to be, it's going to be that same 1.5 that we used for the square. So we're going to do 1/2 of 1.5 times the height of the triangle, which they tell us is 1 centimeter. Now I know I'm mixing fractions and decimals, so I'm definitely going to be using my calculator for this. I'm going to do 0.5 times 1.5 times 1. And I get an area of 0.75. Now remember, that's the area for just one triangle. We have 1, 2, 3, 4 of these bad boys. So we need to multiply by 4. So we're going to do 0.75 times 4. And the triangles have a combined area of 3 centimeters squared. Our last step is going to be to add 3 plus 2.5. So I'm going to do 3 centimeters squared plus 2.25 to get a total combined area of 5.25 centimeters squared. This problem also asks us to determine the perimeter. So again, we're going to pick a corner. I'm going to pick right up here, this nice starting point. If we know that this shape is a square-based pyramid, we know that each of these slanted sides are the same. They've told us that by putting 1.25, 1.25 here. So that means I have 1, 2, 3, 4, 5, 6, 7, 8 sides that are all exactly congruent. So instead of adding 1.25 8 times, I'm going to go like this and do 1.25 times 8 congruent sides. And I get a total perimeter of 10 centimeters. Remember, perimeter does not get that square. All right, so what I want you to go ahead and do is pause my video here. You're going to complete problem number 4 by yourself. However, I've already done it, and I'm going to go over it to save us on some time. Remember, pause the video and try this problem by yourself. I'm hoping that you're back at this video and you've already completed this problem on your own. So what I went ahead and did was I found the area of this shape. So I went ahead and I cut it into 2 parts. I drew myself a little sketch here over on my scratch paper. I went ahead and separated it into a triangle and a rectangle. 1/2 base times height, my base, I figured out was 8 centimeters. My bottom was 16, minus the 8 I already used here, means that this side is also 8. So I went ahead and did 1/2 of 8, which was 4, times the height of 13 to get that measure of 52. Then I went ahead and worked on the rectangle. I did use the full 16, not the 8. That 8 is only talking about this section. In order to find the area of the whole rectangle, I needed to do 16 times 7. 16 times 7 gave me 112. So I added them up and I got an area of 164 centimeters squared. So I'm gonna write that over here on my paper. A equals 164 centimeters squared. Now let's go ahead and talk about the perimeter. Again, I'm gonna draw on the shape. Pick a side to start with. So I'm gonna go ahead and pick this top corner. Again, we're missing a slant, so we're gonna have to do the Pythagorean theorem quickly. We're gonna go ahead and do 13 squared, which is our first leg, plus 8 squared, which is our second leg, to find our third side, which is our hypotenuse. 13 squared is 169, plus 64, and that's gonna give us 233 equals c squared. Take the square root of both sides, and we find that this measure is 15.3 centimeters long. So to find the perimeter, I'm going to type into my calculator 15.3 plus, now I'm drawing the shape, plus 8. Typed it into my calculator wrong, sorry. Plus this side 7, plus this long side of 16. Again, I don't know this measure, but I can look to the other side of the rectangle and see that it is also 7. And then my last side here would be that plus 13. So I get a total perimeter of 66.3 centimeters. Remember, this is not squared. All right, we have 2 more problems. Now, if you notice, this problem is a little bit different. It has something cut out. We call these problems shaded region problems. And the reason we call them shaded regions is we're cutting something out of the figure. So first of all, we know that this side is 15. Because we have these little lines here, they're telling us that all 4 of those sides are congruent. So if this side is 15, we know this side's 15, this side's 15, and this side's 15. This is a good example of one of the problems that doesn't look like a square, but actually is a square. So we're going to find the area of the big shape first. So I'm going to cut my workspace into those 2 sections. I've got a big, like shaded rectangle, and then I have the lighter rectangle in the middle. So I'm going to do length times width, or side times side, and do 15 times 15. And the middle is going to be 5 times 5. Because it has those 4 single lines, they're telling you that all those sides are 5. So 15 times 15 is going to give me, checking my math before I write it down, 225, and 5 times 5 gives me 25. Now, if I were to cut something out, so if I had a whole pizza and I cut out 1 slice, I can figure out, well, there was 8 slices minus the 1 I already took out. So there are 7 slices left over. So I'm going to do the same thing here. I'm going to do 225 minus the 25 that I cut out of the middle. 225 subtract 25 is going to give me an area of 200. And that's going to be millimeters squared. Some of our problems for these composite figures are going to require subtraction. So think about the problem. If I've got 2 shapes and I've put them together, I'm adding them together. If I have 1 shape and I'm removing, you can imagine I'm picking up that rectangle and I'm taking it out, then that would be your subtraction type problems. All right, so our last problem involves these half circles. So we're going to determine the area and perimeter of a figure. Remember, circumference is what we call the perimeter of a circle. So when we talk about the circumference of this shape or the perimeter of this shape, we're going to be using the circumference formula. So I'm going to cut my workspace into 3 sections here. And the first section is going to be the half circle this direction. The middle is going to be that rectangle. And then the third section is going to be the half circle that way. So let's talk about a formula for a half of a circle. It's going to be the same as a circle formula. We're just going to put this magical 1/2 in front because it's half of a circle. So I'm going to do 1/2 of pi times the radius squared. The middle rectangle isn't going to change, so I'm just going to continue to do length times width. Let's write our formula first. Jumping the gun here. Length times width. And then our second half circle, we use the same formula, 1/2 pi r squared. All right, so let's plug in what we know. We're going to keep it as 1/2. Pi, we're going to use 3.14. And now we're going to find the radius. If you're not paying attention, you'll make a mistake here, because it says that this is a 30 meter diameter. So to find the radius, we need to cut that in half. So our radius is going to be 15 squared. Now let's worry about the rectangle. We're going to do length times width, which is just going to be 30 times 50. That's easy. We can do that. And then the other circle, you're going to notice is going to have the same dimensions. So we're still going to use 1/2. We're still going to use 3.14 for pi. And then our radius is going to be 15 squared. All right, so now I'm going to do some quick math here. And I'm going to go ahead, and do 1/2 times 3.14 times 15 squared. And I get 353.25. We're going to leave it with the decimal. Now I'm going to do 30 times 50 and get 1,500. And then I'm going to do the last one of 0.5 times 3.14 times 15 squared. Now, some of you are probably yelling at the computer screen, Miss Bond, we already did that. And you're right. This problem is exactly the same as this problem. So you can save yourself the step and just write the same area. Now, because I'm taking the 2 half circles and I'm adding them to the rectangle, I'm not taking anything out, I'm not subtracting, I'm going to go ahead and add those 3 numbers up. And I get 2206.5, don't forget your unit, meters squared. Last problem, we're almost done. We're going to go ahead and we're going to find the perimeter. I'm going to zoom out just a little bit for you. And I'm going to do it right over here. All right, so first, I'm going to pick a spot to start. I'm going to start right here. There's no really corners because of those half circles, but we can use that little mating point. So we're going to draw the shape. We've got half of the circumference here. So we got a circumference of a half circle. So let's find that circumference. Our circumference formula is 2. Here, we'll use the diameter formula. That'll make more sense. It's going to be pi times diameter. Remember, it's a half circle, so we're going to add a half in front. 1/2 pi times diameter. So we're going to do 1/2 times 3.14 times the diameter of 30. So I'm going to go like this and do 0.5 times 3.14 times 30. And I'm going to get a circumference of 47.1. So I know that this measure is 47.1. Now I can draw the shape, and I'm going to do right here. I know that this top side was 50, so this bottom side is also 50. Then I've got this half circle again. Just like with the area, there's no really point in us calculating it a second time. We're going to calculate exactly the same thing we got here. So I'm going to do plus 47.1 plus this last outside again of 50. Remember, these 30, which are our diameters, are not on the outside of the figure, so we're not going to include those. So I'm going to do 50 plus 47.1 plus 47.1 plus 50 again, and I get 194.2 meters as our perimeter. Remember, this is not squared. Perimeter is just left plain. I hope that this video was helpful to you. I hope that you were able to work alongside with us. Your job now is going to be to flip the paper over or print out the independent practice. Remember, these independent practice problems, I am going to post the answer key. The answer key will post on Wednesdays. That way you're able to check your work, see how you did, and be able to be prepared for your quiz. Don't forget, you've got your check for understanding. All of this work is going to be due by Friday at 3 p.m. So please make sure you get it done. See you guys next week. Bye.